All right, so let's talk about modeling using JPA. So by modeling, typically what we mean is some formal representation of the data, of the structure of the data that we are using, right? What is it that the pieces of information that we want to keep track of? What is the relationship between that data, right? And what's the basic structure? So this is just a snippet of what we've been using throughout the semester, where we have a base class that represents a generic user. And then we have two different types of user, the faculty and the student, that presumably would have their own particular properties that extend the base definition for a user. So let's take a look at how we would model such a class, a user class. Here's a plain old Java object, nothing weird about it. There's nothing spectacular about it. It just declares 4 fields. Notice that the naming convention is using camel casing. They're private, and presumably this also has setters and getters that goes along with this. So that's following this naming convention, and also providing the applicable setters and getters. And at least the default constructor is a requirement by JPA, right? It's a standard referred to as a Java bean standard, right? That a Java is referred to as a Java bean if it has setters and getters, and accessing some private fields, and has a no argument constructor. Okay, and the name of the fields are actually derived from the setters and getters, not by the actual field names. The field names could be whatever you want, right? But the actual deriving the names of those fields is from the setters and the getters, which are public, right? They're publicly available to anyone outside. For this to be a Java entity, we say, has to follow Java Bean naming conventions. So entity is going to be what we refer to as any piece of data. Yes.
I was just wondering about the all arguments constructor. Is that for like development uses?
Just for development users. It's not required. Only for convenience. Yeah. And also, yeah, thank you for mentioning that. If in Java, the default constructor, you get that for free, right? So if you don't do anything, you get it for free. But if you overload it, right, and provide an all arguments constructor or any other constructor, you lose the default constructor. You have to explicitly declare it. Okay. So if you don't declare it and you have some other constructor, JPA will complain, saying that it can't find this, that, or the other. Right. So make sure that you either just have the default constructor explicitly, or it's a default one. Okay. All right. So So these all by themselves, these are just plain old Java objects. There's nothing special about them, right? We want to convert them into mappings to relational tables declared in the schema, right? In a SQL schema, and we refer to them as entities. Entities as something that is that has an instance that has a unique property, and that has it can be found as a single instance and an identity of itself, right? To declare it to be an entity, we use some of the JPA annotations, such as @entity. So @entity declares this class as mapped to some table in a relational database, right? By default, the table is the name of the table is derived from the name of the class. So, for instance, this class user would be mapped to a table of the same name, all lowercase user. You can override that. You can override what the actual name of the table is. We'll look at that in a minute. The other thing that makes this as an entity is the @ID. @ID declares this to be a primary key. So the field private int ID, right, is now going to map to a field of the same name, right? It'll be called ID, and it will be the unique identifier, the primary key. It will be declared with a constraint. This is the primary key, right? meaning it has to be unique, right? And it can participate in a relationship with other tables, right? The table might refer to this record through this primary key using some foreign key declaring some other table. Yes. So meaning all the rules that go along with referential integrity, right? Those kind of constraints that being unique and whatnot, right? They'll be will apply to this field. How many took 5200 or databases? Okay, so maybe a third. All right. So a lot of this might be just very boring to you, but I need to have everybody to have the same conversation. And the other, the only two things that are required, right, for this to be an entity are those two attributes, those two annotations, at entity and at ID. Only those two. The other one here that is listed here at generated value it's an optional annotation that allows us to configure how is that ID being generated, right? Who's responsible for the value of that field, right? Are you responsible when you instantiate this class, or we can delegate it to the database? We can say, hey, database, I don't want to be bothered, right, of coming up with a unique identifier. You do that, right? So here we're delegating. It says this is a generated value. We're not gonna create it ourselves. Instead, whenever we do an insert into a database, right, when this is going to be stored in the database as a record, the database is going to figure out what the unique identifier is. We're going to delegate it. It could be a sequence if it's an Oracle database, taken from some sequence, or if it's in MySQL, typically it'll start at 1, 2, 3, and go up. Different vendors do it differently. Some vendors will start at 10, 10, 20, 30, 40. But anyway, it'll be delegated, and it's their responsibility for establishing that. So you configure by saying strategy, generation type, and different strategies. So if it's an Oracle database, it would be .sequence, right? Because it's taken from a sequence. Identity in MySQL is interpreted as an auto increment, whereas in SQL Server is converted into identity, the keyword identity. Yeah, so that's there. There we go. So we get started there. So this is the minimum we need to have created a user entity. We then need a mechanism that will actually allow us to interact with the database. Right? Declaring the class user only declares the structure of the data, right? What the certain field names and what the data types are and whatnot, but it doesn't actually get it into a database, right? It only declares the instances of the object of the data. We need a mechanism to actually send this object over to the database, right? So to do that, JPA defines the concept of a repository. Right? A repository is an instance, is an object that who is responsible for the actual communication with the database, right? It gives us an API that we can give it instances in Java, and it will eventually convert it into instances of records in the database, right? Through some whatever magic underneath, right? And it declares a API such as .save, for instance. .save, you give it an object, it will generate an insert into a database, right? So these repositories are the go-between, right, from your Java class client, your Java code, and the ultimate inserts, updates, and deletes that go sent out to the database. Make sense? Right. Now, there's a whole bunch of classes and interface that JPA creates for us that know how to talk to different types of repositories. And so relational database is just one type of data storage mechanism, right? There's a whole bunch of other ways of storing data, right? We can store it to just a flat file, right? It could be an XML data storage, right? It could be a JSON flat file. It could be a Mongo database that we're talking a non-relational database. It could be a relational database. So JPA declares a whole bunch of pre-configured, all ready to go repositories from where you can extend. Right? Here we have extended a CRUD repository, meaning this is a repository that knows how to talk to a relational database, and it implements some really basic CRUD operations, right? So all the basic create, read, update, and delete, some of the more basic operations that you might expect, to talk to the database. So for instance, you'll find functions that are already implemented that allow you to save, allow you to find things by primary key, find by some other field, allow you to delete, allow you to update, right? Allow you to do all sorts of some very basic CRUD operations, right? So that you don't have to build them yourself. Right? You can create. The only thing you need to do is configure it. You have to tell it what is it that you want me to CRUD, right? What is it you want me to read or create or update? You need to tell it. In this case, we have provided a user, right? We have declared that this is the class that we want you to CRUD, right? And it also needs the type of the primary key. Right? In our case, it's an integer. Right? So here we have configured the CRUD to use the user class and the integers as a primary key. Also notice that it has no body. Right? So it's opening curly bracket, closing curly bracket. There's nothing in there. Right? So it's only just extending something that is already implemented. Make sense? Now you can add additional functions in here, and we will. Right? We'll add additional. If we want to implement other operations to a database that are not, the basic ones that are provided for you, you can declare a whole bunch of other ones in here, and we will in a minute. Okay, we'll declare our additional functions in there. So this is what JPA would do for us, right? Once we give it the user class and we boot up the server, right? It will send a create. Since we declared it as update or create in the DDL configuration and application.properties, if we configure it as create or update, right? It will send this create instance when you boot up the server. You'll see in the logs, right? It says sending this create instance, this create command. And it'll choose. Notice the naming conventions, right? Notice that instead of first name capital N, right, it replaces it with _n. Right? Also notice that it by default made everything null. Notice that it put the constraint of the primary key in there. It also notice because we use the generate value, right? It added the auto increment in there. See that? Also, it chose some standard sizes for these strings, which is it chose 255 characters for these strings. Now all this can be overwritten, right? You can override if you don't like the naming of user. For instance, a best practice is to use singular in the object-oriented world, but use plurals in the relational databases, right? So this would instead a better name for this class, this table would be users with a plural, even though I don't like plurals. Same thing with oftentimes it's not a good idea to leave things as null, right? Also, you can override the names of the columns. You can override the actual data type that it's using, the sizes. All that is configurable from Java, right? With annotations, you can configure that. Okay, and we'll see how to do that. Also, here just to play around with it, we've inserted just a couple of records: Alice, Bob, Chuck, and Dan, A, B, C, D.